Welcome back to Nasdaq Trade Talks. I'm your host, Jill Malandrino, global markets reporter at Nasdaq. Joining me back at MarketSite, we have Peter Vahansky. He's the vice president over at DataArt, and we're going to learn more about what cloud native is. Great to have you, as always, with us. Thanks for joining us at MarketSite. And let's learn more about this. What exactly is cloud native?
Right. So cloud native is about how do we build and run our applications to take full advantage of what cloud computing brings to the table. So if we know that our ultimate target environment for our applications and systems is this on-demand, rapidly scalable, ephemeral, virtualized environment that is measured and pay-as-you-go, how would we build our applications and run them differently? And it turns out that it's a lot different.
Yeah, it sounds like it's going to change the way you develop, deploy, and operate software. It
certainly has, and will continue to do so because the technology is not static. They're changing very, very rapidly. So think of it this way. You have to do certain things that you don't necessarily have to do in a non-cloud native environment, where you're building certain things in from the word go: security, reliability, resilience, scalability. Those things have to be the considerations of development teams from the very first day of development. So typically when you hear talk of cloud native development, you hear words like microservices, containers, service meshes, agile, DevOps, immutable infrastructure, declarative APIs, that sort of thing. So those exemplify and characterize cloud native development.
So when I cover technologies such as cloud, I always think of an ecosystem. And that's really what technologies have evolved to. Is that correct? Where you're kind of developing more of an ecosystem? And I would imagine the challenges would be integrating legacy systems into that.
Right, there's a lot in there. So
yeah.
Think of it this way. We're thinking about it as modern technologies, instead of a world where technology is basically static, you treat it as static. We now live in a universe where technology is delivered as a set of loosely coupled components that are able to change dynamically and evolve at the speed of business. And that is what cloud native actually enables you to do. So we're talking about things you couldn't actually do before, right? Let's talk about some of the things that go into cloud native, perhaps, to illustrate the point and to begin to understand why those things actually matter. So we mentioned things like containerization, dynamically orchestrated applications, microservices applications, DevOps, Agile. What do those things mean? Why do they matter? Containerization, think of it as the next step in the evolution of virtualizations. So one way to conceptualize it is a very lightweight virtual machine that takes seconds or fractions of a second to deploy and kill, and that means that they're super portable, and they lend themselves very well to dynamic scaling. So if it's important for your application to be able to scale to meet demand and do it automatically, then containerization is certainly a great technology for that. Those applications tend to be dynamically orchestrated, and that means that, yes, you have containers, so you can stand up identical clones of, say, a particular component of your system to meet the incoming traffic, but you don't want to do that manually. So there are state-of-the-art tools like Kubernetes, that seems to be the industry standard today, that do that for you instead of you having to take care of a million things like that. Microservices is a architectural style that enables you to deliver, instead of delivering your big application as one chunk of code that is thought of, conceptualized, and deployed as one piece. Instead, you have a collection of loosely coupled, very small, special purpose, narrow purpose applications called microservices. The importance of that could not be overstated, because this enables you to, because they are loosely coupled, they talk to each other via APIs, you can iterate on them very quickly, independently. They are owned by very small teams. They can be conceptualized and owned by very small teams, and you can make changes very quickly, and you can do it safely without impacting other components of your system.
Right.
So that gives you the agility that you want.
What are some of the security concerns around cloud native?
You definitely have to address security differently in the cloud native world. So there are certain technical and architectural best practices, like there's certain ways to design and not to design your containers. Like you don't store sensitive information on containers. You encrypt everything that you can. You encrypt traffic. You monitor traffic for unusual patterns, because you have massive communication between your components, between your microservices over the network. You follow those best practices, but even sort of on a high level than that, think of it this way. Like, remember 3 R's if you can. Repair, repave, rotate. Repair means you patch everything. Vulnerabilities come out every day. Many times in a non-cloud world, in an on-premise world, and this is where DevOps and immutable infrastructure comes into play, people are hesitant to patch things immediately, and many times you have like batching patches into specific time windows and scheduling those patches, and you will go for weeks or months without patching a known vulnerability. That's a huge risk, potentially, right? You can't, the reasons people won't patch immediately is because their infrastructure is very brittle. Snowflake type server that's very unique, that its configuration is no longer very well known to you, so you don't know if you patch it, you don't know that it's going to stay up and running. It may fall down and never come back up, right? So pets versus cattle is a great metaphor. So you treat a server like a pet. It's very unique. You love it. If it falls ill, if your pet falls ill, the entire family's up in arms. You go into the vet. Versus cattle, where everybody's the same. You know, every single cow, whatever animal we're talking about, is the same. And if a particular server dies, you just stand it back up from a golden image because it's a clone, be it a VM or a container, and you go on with your day. Right. So immutable infrastructure is a great concept that can be practiced in the cloud native world, and is greatly facilitated by containerization.
Yeah, I mean, it sounds like there's benefits to shifting cloud native for sure.
Right. So that's repair. Repair everything, patch everything immediately.
And then
repave is, instead of keeping your server up for a record period of time, like my Unix server has not been rebooted in 3 years and has been up and running, you want the opposite of that. You want to kill off and stand back up from a golden copy clones of your containers and VMs on a schedule. And that means that if there's a malware that's latched onto a particular instance of your service, for example, because of some vulnerability, the attacker was able to get in. If you kill that server, if you kill that particular container and stand it back up from a golden image, the malware is gone. So that makes it that much more difficult for an attacker to execute the attack, right? So you introduce this entropy. You actually ask yourself, how long? What's the longest possible period that I can afford, or rather, what is the shortest possible period that I can get away with restarting, rebooting my containers and my VMs? And that's, so you introduce entropy that way, and rotate the last R. Rotate credentials. Credentials leaking is one of the top 3 reasons for vulnerabilities and threats, and so you should pretty much assume that credentials will be leaked. Therefore, you revoke them on schedule. You rotate them. It's user credentials, it's application credentials, it's database access credentials, it's API keys. All of those secrets, manage them dynamically, comprehensively. Use like an AWS KMS, or like a Vault solution from HashiCorp, or something like that, to dynamically manage your secrets in a sort of a cryptography as a service way.
All right, so every time they ask us to change our passwords, we should actually be grateful that they're doing that.
Absolutely, but you want a machine to be able to do that for you dynamically without you needing to worry about it.
All right, repair, repave, rotate. That's the 3
right.
R's. Thank you so much, Peter, for joining us. And thank you for joining us on Trade Talks. We're Jill Malandrino, Global Markets Reporter at Nasdaq.